I'm Scott Ginder. This is my wife, Andrea Ginder. When we first moved in, it was an interesting experience because we moved in and started to realize that the humidity levels were a little high. And so we got the team together.
I was 9 months pregnant.
And you're 9 months pregnant.
My big goal was getting into a great school district. That was number one. And so we started looking around, and once we found a lot, well, it was done. I was like, well, he'll be able to design a house, and of course our house is built around us. I just wanted a comfortable space for my family. Obviously it didn't have to be super large. It wasn't that kind of footprint for me. It was just having a really great house that is comfortable.
We built a very efficient envelope for the house, and then we put in efficient equipment, and we were realizing that the equipment wasn't working quite hard enough to get the coil cold enough to extract the moisture.
I got to this project after they'd moved in, and with that little humidity problem. You put the computer on it, got all the data. John Clark came out after that, and we assessed the house, and just walked around the house and just, tried to figure out what was going on.
I was really lucky to get the opportunity to work with Scott on design of his house. Just being very blunt about that, by the time I got involved, the air distribution system was already installed. What happened on Scott Ginder's job was the system was installed, and it turned out we needed to have some additional tech support. There were some design decisions that were based on the existing air distribution system, so we just did a load calculation and tied a PVFY upflow air handler into that, and there were some comfort issues. One of the comfort conditions was a moisture control question. There was very high relative humidities, and we speculated at the time that might have something to do with the slab, which had slab edge insulation, and it was only drying to the interior. But it also didn't have a lot of buffering capacity for the moisture. It didn't have a lot of carpeting, a lot of hardwood, big upholstered couches. So we had high relative humidity early on, and we did a check of the equipment to make sure it was working right. Looked around the house, did some data logging, and the decision was made that something is still emitting moisture in this house. And so we suspected the slab. The slab had vapor closed insulation around the perimeter. There was no way for it to be drying other than into the interior. And so yeah, that was an early project that really helps us recognize and underscore the need for dedicated dehumidification, even with VRF. And so we were really lucky to have Robert Madden's DXG, John Clark, come out. And it was really impressive what he was able to pull off. And ever since then, as far as I know, it's been fine.
I was aware of this project after the installation had already been completed. It really came to my attention when I heard that there were capacity issues, so that we weren't getting enough cooling in the house. And that's always, from a designer's perspective, that's like a terrible thing. That's your worst nightmare, is that we've just designed the system and now our homeowners aren't comfortable.
So John Clark made some adjustments to the coil temperature and ran it colder. I think Airride also made some adjustments to the pressure in the line to run it colder, and then that allowed the humidity levels to come back down.
I knew it was going to be modern. I knew it was going to have those design elements to it, which I'm good with, and I knew I'd have new technology. There have been things that have frustrated me. I've been the guinea pig, sort of, but it's worked out.
It's a laboratory.
It is I knew that. I married an architect. It's never done. Things aren't ever done. But it hasn't been an awful experience. It's been great. And actually the Mitsubishi system has been great.
The thing about unitary systems, it's just going to be 100% on all the time until it comes off, on and off. It doesn't have a ramp up or ramp down, so it's harder to control noise. These Mitsubishis are quiet, even the outdoor units. The efficiencies of Mitsubishis in the variable refrigerant flow, you can't beat it.
At this point, it's working and everybody's happy. So, this was certainly the most economical way to go because we have a single ducted unit that's working well.
Our energy efficiency is great. Our bills are low. We also have solar, which has helped quite a bit. Other than that, I think that's the difference.
Yeah, it's quiet, and we get a electric bill that's either a credit or a tiny bill. Not like a $400 bill that you hear
Yeah,
some
it's
people
pretty
get.
great. It's pretty great.
Yeah.